Hi everyone, this is Advanced Statistics for the Social Sciences. In this lecture, we'll begin with an example using categorical moderators in regression. So the example that we'll use for moderators comes from a study on pain. So this is a sample of 218 chronic pain patients, and they're in a study involving an intervention. But the variables of interest we're going to be looking at are things like pain severity, sleep quality, and stress. And actually what we're interested in is how certain variables influence stress. Stress is the outcome. So our research questions are, the first one is whether pain severity influences stress and whether that effect differs for males and for females. So in this example, pain severity is the focal predictor variable because we think pain severity is what might have an influence on the outcome of stress. But we think that that effect might differ for different categories of this other variable, the moderator, which is sex. The key here is that if sex does moderate the association, if there is an interaction between sex and pain severity, then males and females will have different pain slopes. So the slope of pain onto stress will differ for males and for females. It's easier to interpret results from a moderated regression analysis when our predictors have meaningful zero values. Sex is technically already has a meaningful zero value. It's represented as a demicode, which means that we've coded male as 0 and female as 1. Demicodes are something we'll talk about again later in class. They're often used to code variables that are categorical but have 2 or more categories so that we can compare groups to each other. In this case, sex only has 2 groups, so we're just assigning numeric values to male and to female. And then pain severity ratings we have centered at the grand mean. That's the mean of pain severity, the overall mean. So we wouldn't separate out the mean by group or anything like that. Here's a scatter plot with some subgroup regression fit lines on it. So this scatter plot looks pretty similar to other scatter plots we've looked at with regression, especially when we just have a simple linear regression with an x and a y variable. So here our x variable is the pain variable, which is centered. So the center of the plot is 0. And then we have stress, our outcome, on the y-axis. But the difference here is that we have now specified subgroups for this plot such that there are blue dots for the males and red dots for the females. And then I was actually able to get the plot with fit lines on it for each group. So there is a fit line, a regression line here for males and a regression line here for females. Now, just looking at this plot, we would think that the regression line for males, that's the blue line through the scatter plots, looks a lot flatter than the red line for females. And so just looking at this plot with these fit lines through it, our first instinct would probably be to say that, in fact, there is a moderation effect here, that the effect differs for males and females because the slopes of these lines differ. A great way to detect if there's an interaction is to look at these plots and see whether these slopes cross at any point. And we can just barely see where these slopes, the slopes of these regression lines, where these regression lines cross. And it's just kind of beyond the edge of the plot if you look all the way over to the left of the plot. But we see that at some point these regression lines do cross. And if that's the case, then they are not parallel, and there is some difference between the slopes for male and female. So this is the model we're going to use for the hypothesis testing. And so we are going to have pain as our focal predictor, represented by beta 1, and the moderator is sex, that's beta 2. And then beta 3 is going to relate the interaction between pain and sex to the outcome of stress. So now on the bottom equation, I've now rearranged it again, like we did in the last lecture, so that we can look at this rearranged equation and see that the influence of pain onto stress does depend upon sex, because sex is included in the brackets, and that's everything relating pain to stress in this model. Pain is centered at the mean, again, and sex is demi-coded. So this would be the SPSS script for running this model. The first thing we would do is to center the pain variable. So that's the first line of syntax here. We're centering pain at its mean, which I got through a descriptives command. So the mean of pain was 7.54. The second thing we need to do is compute another new variable. And so we actually manually compute the interaction to include in a regression. And we do this with that second statement here. It says compute int equals pain underscore c times sex. So I have created the centered pain variable, and then sex is what my sex variable is called in SPSS. So I'm computing this new variable interaction, or int, that's the product of centered pain and sex. I'm then going to use that in regression. So the code below in the regression statement, if you look at the bottom two lines, we can see that just like always, under the dependent subcommand, we've said stress, which is our outcome. But then in method equals enter, where we usually enter our predictors, we have three predictors entered in here. We have the sex variable, the pain variable, and then we also have that interaction that we've created between pain and sex. So this is what the output looks like, the initial first output looks like from that regression. So of course, as always with multiple regression, the first thing we are going to want to do is look at the model summary and the ANOVA tables and assess essentially whether the overall model is significant. So whether the set of predictors taken together significantly predicts stress. And the first thing we will look at is the omnibus F test in the ANOVA table. And we see that the F is quite large and that the p-value is less than 0.001. And so we would say that taken together, the set of predictors does significantly influence stress. That's all we can say from this table. And then in the model summary table, we look at the R-square and we see that the overall R-square is 0.467. So that is telling us that the predictors, sex and centered pain severity, and then the interaction between pain severity and sex, taken together account for 46.7% of the variation in the stress outcome. So moving on to the coefficients table in SPSS, this is where we will be able to determine if the interaction is significant, significantly predicting the outcome. So the first thing that we're going to look at is the significance column, where we get the p-value for the interaction. And the p-value, I've highlighted that in the bottom row, the p-value is 0.002 with a t of 3.069. So that is telling us that there is a significant interaction between pain severity and sex. And it looks like the unstandardized coefficient for that is 0.390. And we'll talk a little bit later about what that interpretation might mean. Oh, one thing to note here when we are interpreting the coefficients table is that you essentially start from the bottom and work your way up. So, in a sense. So the first thing that we do is we look at the bottom row, which will have interaction, or wherever you entered in the interaction predictor. So the first thing we do is look at the interaction predictor and we assess if it's significant. Now, if the interaction predictor is not significant, then we go on to interpret significance of the main effects. That would be centered pain, severity, and sex. So if the interaction is not significant, we can still work with these other coefficients. If they are significant, then basically we would interpret this as just like a regular multiple regression model, where we would assess the slopes, those main effect slopes by themselves, kind of ignoring the interaction if it's not significant. But if it is significant, then we need to examine further that interaction to determine exactly what's happening and how our predictors are working together in this interaction. So our conclusions so far are that the significant F test tells us that the entire set of the three explanatory variables does predict stress, and with the F test and the p-value that we've already looked at. And the interaction coefficient is 0.390, and it's significant at p equals 0.002, meaning that the influence of pain on stress does depend on sex. But the question is how? How does the influence of pain on stress depend on gender? Or how does it differ for males and for females? This concludes the third lecture on regression model, moderation models. And in the next lecture, we'll go more further into detail in examining these interactions to determine specifically how the influence of pain severity on stress does depend upon sex.